Good morning student. This is the experiment to compare the EMF of two primary cells. I have two primary cells. This is my Daniel cell. This is Leclanche cell. So this is my copper vessel. This is considered to be positive side, and this is zinc rod. It is served as negative. So in this we have two solution. One is copper sulfate, that is this solution. I am diluted it with water, and in this particular pot I have zinc sulfate, and this serves as a negative electrolyte. So in this Leclanche cell I have this carbon rod which is served as positive, and zinc rod which is served as negative, and in which I have ammonium chloride solution. You are working with this experiment, you have to be prepare this freshly so that it can work properly. So firstly, when you start performing experiment, you have to check voltage of this particular cells. Like I am considering this is a negative end and this is a positive end. I have to check its voltage. This is the positive side of this Leclanche cell. I am going to connect this positive to the positive of a voltmeter and negative to the negative side of voltmeter. So I have checked its least count is 0.25 volt. So this is on 7th division. So 7 multiplied by 0.25, that is 1.75 volt. So this particular cell is of 1.75 volt. In the Daniel cell, this is the positive and this is negative. I have to connect this to positive end of voltmeter and this to negative end of voltmeter. See, you can check, this is 5th division of 0.25, so its value is 1.5. So this is the cell of 1.5 and this cell is of 1.17 volt. So when we are connecting this circuit, we have to take care of two things. We have to give its value of voltage E greater than 1.75 and 1.5 so that it can serve properly. So now I am going to connect this circuit. I have to connect positive of this cell and positive of this cell and plus positive of the battery to this P end of potentiometer. So now I have to connect negative of this particular cell, this is Daniel cell, and negative of Leclanche cell and negative of galvanometer to two-way key. So I am going to connect this Leclanche cell here. If I put my key here, then Daniel cell will be activated and Leclanche cell will be deactivated. If I put my key here, then my Leclanche cell will be activated and Daniel cell will be deactivated. Now I have to connect negative of galvanometer to the two-way key and positive to the resistance box and other end of resistance box to the jockey. And now this part is completed. Now I am moving to another end, that is Q. I have to connect negative of emitter to the negative side of battery and positive to the rheostat and other end of rheostat to this. So now what I have to do, I have to put 2000 ohm resistance from the resistance box and do reading for Leclanche cells, and I have to find out null point of deflection at which length it will be 0. So in particular this experiment I have to prove E1, like I told you, E1 is Leclanche, that was 1.75 volt and E2 is 1.5 volt, right? So length L1 is the null length of the Lagrange cell, L2 is the null length of Daniell cell. So in this particular experiment we have to get ratio of these two EMF should be equals to their ratio of their lengths. See, so this is our particular circuit diagram. This is my P end. I have to connect P to positive side of first cell and second cell and positive to the battery, and negative connected to this two-way key, and with galvanometer I have to connect resistance box. Resistance box should be connected to the jockey, and on the other end I have to connect rheostat and rheostat to the positive side of emitter and negative to the negative of the battery. So this is the whole circuit. Now we are going to start this experiment. So for safer side I am taking 4 volt here because I need my voltage greater than the 1.75 and 1.5 volt. So now I am going to check is there any circuit in the current or not. See, you can check there is current in the circuit. So I have to do work for this particular Lagrange cell. I have to point null point for this Lagrange cell. You have to remove this jockey very carefully so that you can get null point very accurately. See, at this particular point I am getting 0 value. This is like, this is my 150 and this is my 50 and 68. At 68 point I got 0 deflection. So this is my null point and this is L1 length for first cell. So now I am going to disconnect this cell from the circuit. I am going to connect Daniell cell L2 in the circuit. Now I have to check L2 for this particular cell. See, at this point this is length of 93. So at this length I am getting my null point of second cell. So this is my L2. So you have to check E1 by E2 is equals to L1 by L2. This is the primary condition of our circuit. So in short we have to prove this length. I guess you can do your calculation part and you will get same ratio of these two values. Thank you.